great. Nobody should be worried about this exam if you study and prepare, because you know exactly what I'm going to ask of you. So if you put in the time, you should be fine. Now, I have one more. Remember the other day I went through some free response questions with you? Remember? And I said, okay, Dad would know these. Well, here's the last one of those. We didn't have time to get to it the other day. We have a system of parametric equations. And as with the other ones, there are a few questions that go along with this. So this is a system of parametric equations. And one of the questions says, find the points where t is, I don't know, some numbers like -2, 1, 4. All right, and then another one says, find the direct algebraic relationship. Sounds way harder than it is, between x and y. And the last one says, sketch it. All right, so here we go. Here's our system of parametric equations. We want to find the points where t is -2, 1, and 4. So what do? We plug them in. So if t is -2, that point would be 3, 4. If t is 1, that point would be 6, 1. And if t is 4, that point would be 9, 16. Easy. Now what does this mean? Find a direct algebraic relationship between x and y. What does that mean? It means get rid of the t. X and y. Get rid of the t. So what could I do to get rid of the t? Guys, come on now. Put your thinking caps on.
X minus 5 equals t.
Yeah, so we could solve this one. Say t equals x minus 5. Right? And if t equals x minus 5, then y equals x minus 5 squared. Which you can FOIL out if you want, or you don't have to, because there's no other terms to combine with it. So that would be up to you. It wouldn't make any difference. It might be easier actually to leave it like this for this part, because now I'm going to graph it. What does y equals x minus 5 squared look like? It's a parabola. Sitting where? Vertex where? Right 5. So a picture of that would just be that. Which, by the way, should include these points. So like over 3 up 4, that looks about right. Over 6 up 1, that looks about right. Over 9, I don't know about that one. It's up there someplace, so yeah. You don't have to, but you can. I mean, I had the equation sitting right here, so that's easy for me to graph. This probably isn't enough points. So if you were going to do that, you would probably want to plot more points.
Would you want us to have a test if you did what you tell us?
It'll say, if I expect you to plot points, it'll say plot points.
For number 2 is the answer what you had circled with the equation.
Yep, that is the equation that shows the relationship between x and y, which is what that means. All right, so now those are the questions that I thought of. So what questions have you thought of? You need to tell me what kind of equation you're talking about, or what kind of problem you're talking about.
Oh, it was the cosine of b is negative 3/5, just going through the different signs, tangents.
So if the cosine of b is negative 4/7, find the cosecant of b, something like that?
Yeah. Just on.
No, we're not gonna do all six. If you can do one, you can do them all, if you know your definitions. There's no question on the exam that's gonna ask you for all of them, it's gonna ask you for one of them. Alright, so here we go, what do we do? Oh, I need another piece of information. Let's say B is in quadrant 2. I need to know where it is so that I can draw a picture of it. So, I'm in quadrant 2. I know the cosine is negative 4/7, so what do I do? Where do I put that?
Cosine x over r.
So
R
x
is always positive.
over r, looks like that.
Yep.
And then I'll do my Pythagorean theorem. So root 33, positive or negative? Positive, we're going up, so that's positive. So now I can answer any question I'm asked about that. If I know my definitions, any one I can do. I said cosecant, okay. Cosecant is opposite, a reciprocal of sine, so it would be hypotenuse over opposite. So 7 over root 33, or 7 root 33 over 33.
Are you allowed to have the root at the bottom?
Have I left it at the bottom?
No.
No.
B said 4.
Just do it the way I do it. That's how we get along in life. We just do it Mrs. Ford's way and everybody. All right, another question.
So that's what equals b. Equals.
That's the cosecant of b. That was the question. Dylan?
On the semester one review package, question number 1 is
What's the question?
X minus 3 over x minus 3 over x plus 1 plus 3 over x squared plus x.
What are we supposed to do with it?
Just this song.
Add it or solve it.
So the directions say so. I don't want to do the exact problems on the sheet because I'm going to do those at the review session. So I just need to know what kind of problem it is. Let me see your review sheet. I can't locate it. Oh, here it is.
Number 1.
Alright, so it's solving a rational equation. Alright, so now we got a question about solving a rational equation. So, that would be something like this. Alright, so the first thing I want to do when I solve an equation like this, the first thing I want to do is get that guy factored. So I'll get him factored. And then who remembers what we do?
Multiply by both.
We get rid of all of those fractions. So we're going to multiply through by the common denominator, which is x minus 1, x plus 2. So then this will cancel and we're left with 3x squared minus 3x. That will cancel, so we're left with 2x plus 4. And all that cancels, so we're left with just 5. So now we have a little quadratic, so we'll clean things up. Is that right? And I have to solve that. Sometimes that factors, sometimes it doesn't, and I don't think this one does. So how am I going to solve that? I'll use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I did my math right, those are the answers to the question. You do want to be careful on ones like this. If we happen to solve and get -2 or 1 as an answer, we'd have to throw them out because those would be what we call excluded values. Those make the denominator 0. Didn't happen, so we're good. All right, who else? Yep, Isabel.
Writing Cartesian equations.
For
The function is defined symmetrically.
That's exactly what I just did. So, I mean, I'm happy to do another one, but I just did that. That, it says, take a system of parametric equations and get rid of the t so that you have an equation in just x and y. Cartesian means x and y. This is the Cartesian coordinate plane. That means x's and y's. So, in this case, I would just say probably x minus 2 equals t. So y equals 3 minus 4 times x minus t. So y equals -4x plus 11. And that would be my direct algebraic relationship or my Cartesian equation. Do want to point out the test is multiple choice, like I said, part of it is. So you want to make sure the answer may not be written like this. What if the answer is written like this? Is that the same equation? Yeah. So before you mark none of these, you want to make sure that you don't have your answer down there in just a different form. All right, who else? All right. Anybody else? Take t by itself, substitute it in to the other equation in place of t. It's just substitution, just direct substitution. And then collect by terms. Distribute and collect by terms. I don't know what you mean by formula. Look on the review sheet. Are there any on the review sheet? If there are, then yeah, there will be.
We do a problem similar to the 19.
What does it say?
The first money that you have, you deposit $3,000 in an account, paying 2.5% compound interest.
Compound quarterly?
Yeah, or 20 years.
All right, so the question is, how much money will you have if you deposit $8,200 at an interest rate of 1.25% compounded monthly for 13 years? How much money would you have in the account if you deposited this much at this interest rate compounded monthly for 13 years? So, what formula is that going to be? No, it is not PERT. The only time you're going to use PERT in a money problem is when it says compounded continuously. This said compounded monthly, so it is this formula. How much will you have? That's the question. If we start with 8,200, interest rate has got to go in as a decimal, compounded monthly for 13 years. Now, a lot of times when we do these problems, we use logarithms. Are we going to need logarithms for this one? No. No. The only time we use logarithms is when our variable is up here. Because we need to pull it down. We need to get it down. But here we're all good to go. So we just type that in. I always start with the parentheses. You don't have to. Get my parentheses typed in, then I raise it and then multiply it by 8,200. So I came up with $9,646.06. Michael, you didn't have to give up that seat. You were here. He wasn't. You could have stayed there. We don't have assigned seats.
It was just either though.
It's first come, first served.
No, it's all good. What is that?
All right, so that's what I got. I would suggest that maybe if you have issues with this, that you be typing it in right now with me, so that you know how to type it in on your calculator. Because I'm not answering questions on exam day.
Can we do one of these with the logarithm?
So then the same kind of question, but a different ultimate question might be, I'm depositing $8,200. I want to end up with $10,000 in 16 years. No. The interest rate, I want to end up with $10,000. The interest rate is 1.25% compounded, let's say quarterly. How long will it take? So I'm going to put in 8,200. I want to end up with 10,000. I've got that interest rate compounded quarterly, and how long is it going to take? Well, now you see, same formula, but your variable is in a different spot. Now your variable is up high. It's an exponent. So when your variable is an exponent, you know you're going to need logarithms, because that's the only way to pull it down. So I'm going to take the logarithm, but before I take the logarithm, what do I need to do? Divide by 8,200. So I'm going to divide by 8,200. So I basically have 100 over 82 equals 1 plus 0.0125 over 4 to the 4t power. Now I can take the logarithm of both sides, and when I take the logarithm here, that exponent's going to come out, right? And that's why I did it. That's why I took the logarithm, to get that exponent as a coefficient now. So to get my answer, right, this is what I'm looking for, I'm going to have to take this log of 100 over 82 and do what with it? Divide it by 4, and the log of this thing. Now, if you're going to do that all in one step, make sure you have parentheses around that whole denominator, because you're dividing by two things. You're dividing by the 4 and the log. Some people divide by 1 and get an answer, and then divide by the other one and do them separately, and that's okay. If you do it as one, you got to have those parentheses. So let's see what the right answer is. Looks like it's going to take about 15.9 years to make that happen. About 15.9 years. Okay? So we should probably be typing that in to make sure we know how. All right, what else? What else? You think we're ready? Nothing would make me happier, Clara.
When it's talking about like the f of x and the g of x, and you like plug it in, but then when it says like if you're talking about the g of x, if it's g to the -1x,
That means inverse.
Okay.
That means finding the inverse. And we practiced one of those on the mini review.
Okay, that's what I thought.
What does the problem What does the problem look like though on that?
This one, the g of x is 3x minus 2.
Oh, that would be easy.
Yeah, so then
That's
you would just
another
put the x
easy
and
one.
y. Okay, that's what I just
Yeah,
did.
this means find the inverse.
Okay.
So that's where we practice that on the mini review.
Okay.
So that's where, whoops, I forgot to switch my variables. So that's where I switch my variables. And then solve for y. So the inverse would be x plus 2 over 3. Which, oh, by the way, if this is a multiple choice question, that could be written as 1/3 x plus 2/3, right? It's the same thing. Just be careful because the answer choice may not be in exactly the same form you have when you solved it. All right? What else?
Number 4 on the Precal A review.
What does it say?
It's like -2 is less than or equal to 4x minus 8 is less than 6. It says solve. Is that easy?
Yeah.
Oops.
What is it?
Looked at it.
This is a compound inequality. The easiest way to solve it is just to get x by itself. That's what we do when we solve. We get x by itself. So we need to get rid of that 3. So we'll add 3. And then we need to get rid of the 7. So we'll divide by 7. So x is between 8/7 and 18/7. That would be the answer. Now, it might be written as an interval, which would be like this, right? Might be written as an interval instead of as an inequality. Like what? Find a question on the review sheet and tell me what it says about sine and cosine graphs.
Are those on the test, the graphs?
Honey, what's on the test is what is on the review sheet. I don't know. I feel like I've said that like 15 times, and maybe your other teachers lie to you, but I am not lying to you. I want to talk about what's on the review sheet. That's what I want to talk about.
Come on, Rachel. That's on this board.
If there's one on there, that's what we need to do. Okay, what's it say? Did you have one? Oh. Cassie? Okay, so find the intervals. So you have to have some kind of, does it give you an equation or a picture?
A picture.
All right, so you've got some kind of a picture. Like, I'll just go back to my old standby picture that I use all the time. All right, so I've got this picture. This is f of x. And it says find the intervals where the function is increasing. Now, what does increasing mean? Going up. So as I start here at the beginning of this picture, where is my pencil going up? Well, it's going up right there. So that is from -3 to -2, from here to here. My pencil's going up. And then again, that means or, again, it's going up from here to here. That's the answer to the question. Where is my pencil going up? It's going up between here and here, moving left to right. So from -3 to -2, I'm going up, and then again from 2 to 3, I'm going up.
And what was that question again?
Where, name the intervals where it's increasing.
So with those, you would never use the closed.
Never.
Okay.
Because at this point, specifically, you are not increasing or decreasing, you're just
okay.
sitting there. All right, what else? Have you found one, Sarah?
No, I didn't see.
Okay, then we're not gonna worry about that right now, are we?
Yep, because it's not on the test. Right?
What's on the test is what's on the review sheet.
Yep, that's what I'm saying.
Yeah, I know, surprise, surprise. What's on the test, Jack?
That's all already got.
All right, what else?
Which one of the graphs can't have the amplitude? Those.
Nothing, anything that, if you had to have a ceiling and a floor to have amplitude. So if you got a ceiling and a floor, you have amplitude. If you do not have a ceiling and a floor, you don't have amplitude. This curve, we would say has amplitude.
What would the amplitude of that graph be?
Half the distance from the top to the bottom. So the bottom's at -2, the top's at 1, so it'd be 3s. Is amplitude. I don't think that's on the exam. Read the exam review question. All right, last call. You were supposed to have done a little prep last night, which I can see no one did. Cassie? Find what? Okay, there are 4 symmetries particularly, so I'll have some equation here, let's say 2x minus x cubed. All right, yeah, that's good. Okay, so we're going to find the symmetries here. We have symmetry about the x-axis, about the y-axis, about the origin, and about the identity line. Those are the 4 main symmetries. Many curves have a point of symmetry. We did not discuss that yet. So when we discuss symmetries, we're talking about the big 4. All right, so how do we tell if something has any of these symmetries? Do you remember? There's rules for all of those. Okay, trouble in River City. This is something you need to know if you're going to get this question right. Because you're going to have to test for the symmetries. So how we test for the x-axis is we change all the signs on y and see if it matters. Because if you are symmetric about the x-axis, that means your positive y's and negative y's have the same x value, right? So the sign on y shouldn't matter. So if I change the sign on y, I would have this equation. Is that the same as the original equation? It is?
Oh, yeah, divide by
This one would be -2x plus x cubed. Is that the same as the original? No. So there's no symmetry there. So that's no. Now, to test for symmetry about the y-axis, we change the sign on x and see if that matters. So that would look like this. So -2x, that would be plus x cubed. Is that the same as the original equation? Is that the same as the original equation? No. So there's no symmetry about the x-axis either, or y-axis either. Now, to test for symmetry about the origin, you change both. Because if you're moving across the origin, you're going from plus plus to minus minus. So that would be is that the same as the original equation? Yes. So that one is yes, it does have symmetry about the origin. And then the last one is the identity line. Anybody remember that one? You change y and x. Would that be the same? Is that the same as this? Are those two equations the same thing? No, not even close. So the only symmetry this one has is about the origin. It's definitely possible that a curve would have none of these. Most curves in the world have none of these symmetries. They're special if they have any of these. This one happens to have this one. Okay? Alright, so what else? I think that's one you probably want to all put a star by because you don't seem to remember that. Okay. What else? What else? From the review sheet. This goes from P to 4-3. Chapter P to 4-3. No. Cassie? Okay, we already did one like that. We did one like that, not today, but that was on my extra practice ones I did. Yeah, so what was given in that problem, Cassie, is a bunch of data. You got minutes, and what was it, detentions? Okay, so you're gonna read the question, and you're gonna set up ordered pairs, however many you're given, right? And then ultimately, what does it say? Okay, write a quadratic equation. So that tells you you're going to put these points in, however many you're given, and you're going to use quadratic regression on your calculator in StatCalc, and it's going to give you an equation, just like we did the other day. We did a quadratic the other day. And then probably it says, you know, okay, so if he's 18 minutes late, how many detentions does he get? And you would plug in 18. Okay. Remember doing that the other day? That is exactly the same problem. So you definitely want to know how to do that. That's on the review sheet. So do you think it might be on the exam?
Yes.
We're starting to get it now. Good.
I did a question.
Huh?
I did a question.
Yeah, is there any bonus on it?
No, the bonus is
Is there a birthday bonus?
I have already given you virtually a copy of the exam. Come on.
I haven't even done my
Do we get like a birthday bonus?
If your birthday's on the exam day, you should get
Canned food gives us
Canned
3%.
food Jackson, I asked all of you, okay, you don't check Schoology, because what I asked you to do was, I put in there to have you check, because I put in the points I had recorded. I am not on exam day or over Christmas break. I am not tracking down your cans. I have put those points in, and it is your job to tell me if they're right or wrong. I did that a week ago.
What's it?
I thought it was
So is it not 3%?
I thought it was 3% of the finals.
It is. It's put in on the exam for the semester 2. If you look at your semester 2 grade, you will see a column that says cans, and it should say 0. Well, it should say 1, 2, or 3. Yours says 0.
Out of 3.
Well, it says 3 out of 0.
3 out of 0, yeah.
Yeah. All right. What else from the exam review sheet? What else?
There's a bunch of questions under as the next equation, and then it says where's like graph a tangent to the x-axis.
Where is the graph tangent to the x-axis?
Oh yeah.
So it must be some kind of polynomial function. Is it factored or
It's
so it's like x plus 1, x minus 3 squared, x plus 5, or something like that.
Yeah.
All right, it says where, there are some questions about this, and it says where is the curve tangent to the x-axis. Now, think about that. If you're going to be tangent to the x-axis, then that means you just touch it, right? So in other words, I don't know whether you're coming in from the top or the bottom, but if you're going to be tangent to the x-axis, aren't you bouncing off? That's what tangent means. Tangent means you just touch it. That's what tangent means. So if you are tangent to the x-axis, you're not going through it, you're bouncing off of it, you're just touching it. What do we know in equations that make curves bounce off? The squared factors bounce off. So where would this curve, without graphing the whole thing, I know it's tangent to the x-axis where? At 3. 3 comma 0 is where it's tangent. Because here it passes through, and here it passes through. Right? It has zeros at -1, 3, and -5. That's where it has x-intercepts, or zeros. What is the degree of this polynomial? 4. That's even. What do I know about even functions? Start up, end up. So this guy starts up here and he comes down. What does he do when he hits this point? He passes through. What does he do when he hits this one? He passes through. What does he do when he hits that one? Bounces off. Where is it tangent to the x-axis? At the point 3 comma 0.
It bounces because it's squared. When it's cubed, it does. Is this?
What is it?
Yeah, what's the
It's
meander?
extruded.
Like a
Goes
tangent.
through, but it's not a tangent.
What?
All right, what else?
If it's odd, it's.
What?
Degree 2.
Degree 2 is a parabola, dude.
Oh my
Come
God.
on. Degree 2 means x squared.
No, I was asking. Did you say what's the degree?
The degree is 4.
We don't have to find out the range.
Because if you multiply this all out, Jake, which I don't ever want you to do, but if you did multiply it all out, it would be x to the 4th. That's even. Yep. Don't throw things. All right, who else? Who else? Hood's off. No hoods in the building. Alright. Who else has a question about the sheet?
Album chapter.
You have one? What is it, Jack?
I just wanted to see. Why? Can we just do some logarithm there?
I need you to give me a problem. So tell me, what kind of problem you want me to do? When you say do some logarithms, I don't even know what that means. So find a logarithm problem you want me to do, and I will gladly do it. Tell me what it says.
Says write as a single logarithm.
Alright, so this is a logarithm question. I did one of these on the mini review actually, where we have something like 3 log n minus 4 log n, and we want to write that as a single logarithm. This was on the mini review. We did this, it was an ln, but it doesn't make any difference. The rules are the rules, no matter what base of logarithm we have. So we're going to put these two together, but before we can put them together, we have to deal with something. What do we have to deal with? You have to deal with these guys. They are exponents. So this is the log of m cubed minus the log of n to the 4th. Now when I put them together, inside the parentheses, since they're being subtracted, I will put them together as a division, and it would look like that. So that is one logarithm expression, started out as 2, put them together, this is how they go together. Huh? No. All right, what else? Two more questions and then I'll let the boys go potty. All right, 2 more questions. Let's get 2 more questions.
For number 10, where you have to do the PRRs.
Okay, so what is the question? Find the PRRs?
All the possible roots and all the actual roots.
Okay, now we did not yesterday find all of the actual roots. So let's suppose we have a polynomial like this. How many roots does this problem have? Guys, how many answers, how many roots does this problem have? 5. Okay, so I am looking for 5 answers to this problem. Okay, now, I don't know exactly how the flow of the question is going to be, but certainly PRRs, that was on the mini review, right? So, what are the PRRs? I'm going to start figuring these things out. So the PRRs will be factors of 8 over factors of 1. All right, so then I'm going to start guessing numbers from this list and hoping that something gives me 0. So I'm going to try 1 and see what happens. That's a -8. There it is, right there. We got a 0. So the minute I find one, anything that gives me 0, the minute I get a 0, what do I do with it? Divide it out. So out comes the 1. And I divide exactly the number that I plugged in. So if 1 gave me 0, then 1 is what I divide out. All right, then what? I keep going. Now I'm down to x to the 4th minus 2x cubed minus 7x squared minus 2x minus 8. And do remember, if your polynomial had a missing power, if there was something skipped in there, like x squared was skipped, remember in the division you have to put in a 0, right? Some of you, I remember, didn't do that on your test and you got all confused. You have to put in 0s if you have anything missing. All right, now I start all over again, and my PRRs are still the same, aren't they? So, I don't know. Let's try 2.
Did we do some division again?
Yep.
You can't use the PRRs that you have with the other one.
This one has the same PRRs. So I'm using 2. But 2's not going to work, I can tell that. How about -2? -2 might work. That looks promising. 32, 4. Yep, there it is. There's another 0. Okay, good. So now I'm going to divide out a -2. Okay. And what's left? I divided out my -2. What's left? X cubed minus 4x squared plus x. Oh, it groups. So I'll go ahead and group it. Remember, if it groups, you could group it. You could also keep guessing, right, Cassie?
Do you stop when it groups? Like,
What do you mean stop?
dividing them all out?
Yes, yes. But you don't have to group. If you don't notice a group, you could keep guessing. You would guess on this one now. Now the PRRs are down to just 1, 2, and 4 for this one. So those would be the numbers you'd be guessing. But this one does group. Alrighty. Okay, so now I'm ready. The question was, what are the actual roots? these were the possible rational roots. Now I can tell you what the 5 actual roots were. They were 1 and -2 and 4 and plus or minus I. Because if I solve that, x squared plus 1 equals 0, x squared equals -1, and x equals plus or minus I, the square root of -1. So there would be the 5 actual roots. So difference, read it carefully, there's a difference between possible rational roots, that's just your list. Actual roots means you have to go through and actually do the problem. Okay? All right, one more question and then we can go to the bathroom. There'll be great wailing and gnashing of teeth next Tuesday. Come on, let's use this time productively.
The greatest exponent shows you how many answers there are.
Dylan, what are you doing on your iPad?
Do you have to know all the BFF functions or just the exponential functions?
You need to know all the BFF functions because a question might be, what's the domain, what's the range, whatever. Remember, we had one of those on the mini review, and it was the square root function, I think. Same thing there, only I picked the exponential function. So I'm going to pick a function, and you're going to have to answer a question about it. So yes, you need to know all your BFFs. All right, one more question, let's go. Somebody find one.
The absolute value of the
Plus or minus 360.
Yes.
For number 11, I forgot about the absolute values.
Number 11 is solving an absolute value equation. I don't care how you solve it, somehow you got to solve an absolute value equation. So something like the absolute value of 2x plus 5 minus 3 equals 8, or something like that. You have to be able to solve that. So what do? You got to get that 3 over there. No matter what you're doing, you got to get that 3 over there. All right, now what?
Don't you do 2x plus 5 and 2x minus 1?
You never do that. That's a no. Now, what you can do is say 2x plus 5 equals 11, or 2x plus 5 equals -11. That's what you do. No. Say what you mean or don't say it at all. So 2x equals 6, x equals 3. 2x equals -16, so x equals -8. So you get a couple of different answers. That's one way of doing that problem. So if that's the way you remember, then that's what you'll do.
Is the answer both of those, or do you have to pick
The answer is both of those. All right. Okay, so who has to go to the bathroom first? All right. Oh, time out. No. Yes, Charlie asked first. We go one at a time. I feel like I'm teaching